Okay, Nearpod. Okay, now on that, it's probably waiting for a code. So on your Nearpod, here's a code I would like you to use. Okay, it's DLINR.
Is this caps or?
Capitals. DLINR. And type that in a little code space. I don't know if it opened up that website for you automatically, but if it didn't, you can type in Nearpod because it will only allow that website only. And now you'll have to type in your name. Just type in, try to type in your name. Don't try to type anything weird. But DLINR. This is something I want to try today. It's nothing that we're going to commit to. It's something that I thought it was kind of cool, the concept, and I want to see if it works. So you guys are kind of my guinea pigs today. I want to see if this will work today. So, second period, yeah, it didn't work so well. The internet went out for a while.
Oh, so weird.
Awesome, so you're guinea pigs today. Alright, so did everyone get logged in though? I'm just going to walk around the room and kind of check, make sure you type in your name. Okay, hit submit, you know. But what it is, just so you know. Alright, what this is basically a big interactive PowerPoint. So, because some people say that they can't see the board, they can't see, or you're fighting the person in front of you, you're trying to look around their head. This way, you can watch me do my PowerPoint, but it's on your computer actually going when I click. Does that make sense? And it didn't require you to have any logins, any extra passwords or anything. You didn't have to give any personal information. But I thought this was kind of cool that it would actually work. Now, there's some other cool concepts to this that I want to see if it actually works for you guys, because the first class, it did. So, here we go. So now that we're logged in, here's kind of the cool concept. Let me bring it up here. All right. So here's why I thought this was kind of cool. It actually should change your screen and allows you to do problems in front of me. So here's what I like. Now I know you really can't see it; it's kind of tough. You can see the problem on the board here. I'm going to put the lights just so you can see this. Okay, you can click the drawing tool. Click the drawing tool, and I would like you to attempt this problem. Now, if you can't see the question, you're like, "Word, I don't even know what the question's asking for." It's in that upper left corner. There's a little blue arrow. Okay, it's an arrow in the upper left corner. If you click that, it'll drop down a little questionnaire. So I'm going to walk around and see. I would like you to try to find X and Y. You can put it on notebook paper, and when you have your answers, just write them on the actual picture. Now you can draw, because there's a little draw tool, or you can just put in text, because you can type with your keyboard. Okay? And I want to see if you guys are, if you can. Now once you have your answers written in there, again, put it in your notebook. You should have your notebook open anyway, because you should be trying to attempt to solve this. Now some of you can probably do it in your head. These are pretty straightforward. But I want to see if you guys can work this website without me telling you kind of what to do. Trying to find X and Y. So here, the questionnaire is up here.
What?
Yeah. So if you click draw, it'll actually show it. So
What do you?
actually try to.
Here we go.
Let's see.
So wait, is this the length of this, or the length of this?
X and Y, so you're going to find the numbers for X and Y. That's an angle.
That's an angle.
That's a degree on it.
Oh, I see.
So hey, if you can't see it, the picture's on the board, sorry. This is something that I'm trying to get figured out. The pictures don't look right, sometimes they're cut off in the bottom. Some people's it looks normal, some people's it doesn't. Like, how do you do that? How do you do that? How do you hide that?
How do I hide what?
How do you hide that bottom drawing?
I don't know, did I? Oh, you gotta draw on it.
Yeah, it disappears in the draw.
Oh.
Oh, there you go. Okay, makes sense. Because the first class couldn't tell me how they were doing it. They just knew what to do. So, and I thought it was kind of fun. It's an interactive PowerPoint, so it allows you to answer questions, submit answers, and then I can see what you're doing as we do it. And then when I click the next slide, it just automatically takes you to the next slide. So even if you weren't done, I can just move on.
I need this
kind of see.
question thing.
So. What, just moving on? Yeah, I know. But I want to see if you guys can get this thing working, see if you can submit answers, what it looks like on my end. I think it was kind of fun, kind of cool. Maybe I'll use it from now on if you like it or not. This is more interactive. Like sometimes PowerPoints can be very, very boring. You're just watching me lecture at you. But I want to get some points where you can actually answer questions without having to feel like you have to raise your hand or having somebody like blurt out the answer when you have your hand up. That type of thing.
Wait, can you see this on the board?
Yeah, so I can actually see your responses, which I think is really cool.
So like,
So here, let me show you. So here's the responses that I can see. Now, hopefully they're school appropriate. But when you submit, so somebody submit their answer. Okay, so Breeze just submitted. So here's the answer that that Bree had. Okay, boom. So she submitted. Submitted Y was 9, X was 8. That's how she did it. Now maybe you wanted to do text instead of drawing. You could do the typing and put in text in there. Okay, I have 4 people out of 9 that have actually submitted this. Okay, so let's go to Brandon. So his is really tiny, but I can actually show you his answer. He typed it in. Unless you're really expertly, like, proficient at using the trackpad. I think that was with text. But here's the cool part. If I found an answer that was so special, like when you guys are submitting, right? I'm still waiting on some people. But if let's say I wanted to share Breeze out. I can just click share, and it should show you. It should automatically bring up Breeze in front of you, and it'll actually submit it. I know it's taking a little bit longer than usual. This is what happened in the first class today, that they're really struggling to try to get people's answers submitted. Okay, questions, comments about my problem, okay? Or about this one in particular. Did everyone get a chance to kind of answer it? Anyone struggle at it? I wish this would just come up full screen so you can see it, but I have to double click it. All right, now here's why. Now, Bree, you're the first one to submit answers. Why is X an 8?
Because 4x minus 17 is equal to 2x minus 1.
Yeah, actually right. Yeah, you're absolutely right. These are equal. The opposite walls are equal. It's still a parallelogram, right? So the idea is that you can set those equal and actually solve. So you can set this equal to 2x minus 1, and then just solve. You'd add the 17 across, so negative 1 plus 16, or plus 17 is 16. So that makes 16 here. And when you move the 2x across, you have to subtract it, so we get this. So you're going to subtract the 2x across. So this, what we get, this led to her x being 8. Okay, and then the other 2 angles are equal. I had a lot of people attempting today where they're trying to add their angles to make 90s. Those angles are on the opposite corners, so you have to actually solve. Okay, are we good so far? Okay, hopefully that made sense. Now, I'm going to move on. Sorry if you were still trying to submit. Apologies, don't mean to be rude and move away from you, but yeah. All right, we're going to just move on. Let's see if it actually clicks. I don't know if it will actually move. You might have to click grade or done or dismiss or whatever. Hopefully it takes you to the next slide automatically. I don't know what it's doing yet. It might take a little bit here. It's definitely catching on. This is something we figured out in the first class. It was when the internet is slow, it just crawls, and then finally it'll catch up all of a sudden. 9 people can bring this website to its knees, so that's something we'll have to figure out. Okay, all right, I'm going to zoom in here. So if you're writing notes down, this is what our notes are today. We'll just kind of move on. It'll catch up here in a second. All right, goal today. I want to review some of the properties we've had previously. The definition of a rectangle, some of the 2 properties we had Tuesday and Wednesday this week. Just to kind of clarify. Then we're going to get a new definition today. We're going to talk about what a rhombus is. We're going to do that definition today. Once we get through the definition, we'll do an example of it. Hopefully the website will catch up here in a second. And then we have 2 properties I'd like to cover. And as we do these, as we go through the examples, one of them in particular is actually super, super challenging. The example I give you, because I want to. It really reviews all the stuff that we've previously done. Okay. All right. Questions, comments about what we're doing today. Now, I know we're not going to get to square. The goal is to kind of give you the intro to this today to kind of show you what we're doing. and then maybe at the end we'll do some review problems. So hopefully we can kind of get going here. It doesn't look like it's clicked to the next slide yet, for some of you anyway. So, okay. I'll just click and maybe it'll catch up on this next one. All right. Okay, I'm gonna click to the next one. Now, if you can't see this, it'll eventually catch up. It always does. All right, here's the first slide that if you don't have your notes that you should. Okay, reviewing. We have properties of rectangles. So rectangles are a quad with opposite sides parallel and 4 angles. That's something we talked about the last couple days in here. One of the properties about a rectangle is that the diagonals are equal. So in fact, I'm going to zoom in on that. This is something that I want you to kind of look at. On this picture right here, we knew that these diagonals are the same length. Right, this one right here and this one. That was unique. Whoa, what happened here? What? Whoa. Retry. Okay. These diagonals are the same length. So one of your homework problems that when we were doing the little group activity, one of your groups had a problem where this angle was 65. I don't know which group it was, but one of the groups in here had an angle where this was 65. And the question was, find this angle right there. The angle that was right in the middle. Okay, I don't remember which number that was. It was like 13 or something like that, or 12. But you had to find that angle. Well, what you had to know is that if these diagonals are the same length, all 4 pieces are the same. Because if the diagonals are the same and they still split each other in halves, they still bisect each other, according to 6.7, that this triangle right here is isosceles. This triangle is isosceles. And if it's isosceles, that means that 2 walls are the same, and namely 2 angles are the same. So I could find the 65 in the corner because this is the base. So the base angles are the 2 that are equal. And then this angle, the mystery angle, is the one I have to find. Because if I find that angle, which it turned out to be 50, you could transfer it across. And that would be the question that we had to answer. That was one group's problems that we had yesterday. The other type of questions we had, I think there was one group in here from the last couple days where they were just given like the opposite wall. Like they were given like this wall's a 2, and you had to find this wall. Well, what would that wall be? It'd be 2, right? That wall's 2, because it's still a parallelogram. Right? If you look at the definition, these are parallelograms. So it is still a parallelogram, so that the walls are still equal. Okay, so the opposite walls are equal, opposite angles, all that good stuff. So hopefully that makes sense to you. Get rid of all these. Okay, has it caught up yet to you guys?
I tried exiting out and exiting back in, it's
Still weird. Alright. A little finicky. We'll learn. And when it does work, it'll look good. The first class, it caught up like a slide or 2 later. And it just suddenly started working all of a sudden. Alright. Now the last one, the diagonals are equal, then we could prove that it was prove that it's a rectangle. This is the last one we did. I think this was Wednesday we talked about this. That if you know the diagonals are equal, not fair play. Yeah, we're not gonna watch a movie. Yeah. Alright. Anyway. Okay. But anyway, on this particular problem, I want to make sure that you realize when we did this. Okay, so when we did this problem, these angles in the corners had to be 90s. So that's what we talked about. Let me see if I can hit refresh and see if it'll take you to it. I just brought this website to a crawl. Okay. Well, always have a backup. Always have a backup. Here we go. Alright, so the angles in the corners are 90. So that was something we did on Wednesday. Last thing that I want to, or the first thing I want to talk about today with the new stuff. Definition of a rhombus. This is something you should write down your notes. Definition of a rhombus. It's a parallelogram that has 4 equal sides, 4 congruent sides. It doesn't have anything about the angles. It just talks about the walls being the same.
Isn't that like a diamond?
Yeah, it looks like a diamond. Yep. Well, in fact, let me just give you that picture. There you go. Looks like a diamond in shape. Not a kite.
Like a smush square.
Yeah. Yeah. That's what I think of. Yeah. Square that's been stepped on a little bit. It's bent. That's the definition. This concept is what we're going to be working with for the next couple properties. So opposite walls are parallel, yeah. So the idea is on this one, the question was, are the opposite walls still parallel? Yeah, because here's the big deal. It's still a parallelogram. So it still has all the properties about a parallelogram. So the opposite walls are still parallel. You can still put the little arrows in here. Top and bottom are parallel. The other thing that we also know is that the opposite angles are equal. If I were to draw diagonals in there, they would still bisect each other. The only thing we don't have is we don't have 90s. So the only property we don't have on this picture is that we don't know that the corners are 90s and that the diagonals are the same length. In fact, they won't be. Concept here, just take a look at this. And look at how long this diagonal looks. What is that, like 8, 9 inches, something like that? Maybe a foot in length. The other diagonal that's going through it,
2 feet.
yeah, 2 feet, way longer. It may not be double, but it's definitely way longer than the other one. So they're not the same length, so it's definitely not a rectangle. So we know that. But the concepts, the major properties about parallelograms still apply. Opposite walls are equal, opposite walls are parallel, opposite angles are equal, diagonals still cut each other in halves. But we just know that the 4 walls are the same. Okay, questions? Okay, let's go through notation here. Okay, notation. Notation, rhombus, F, G, H, J. That's the notation that you want to write down. Now, since it is a parallelogram, you guys have every option, if you want, to draw that mock picture of it. So when you draw the mock picture of it, you have all the walls. You have to mark them that they're all the same, and then you can put the letters after it.
That's instead of writing rhombus?
Yeah, so instead of writing rhombus, you draw a mock picture, and then you can just put your letters down, but you just have to go on a circular path. So if you start with J, just spin around the object and go all the way through. All right. Questions, comments about any of these problems so far? Perfect. Let's get to the next one here. Okay, first property today. 615. Here you go. 615. Parallelogram is a rhombus, then the diagonals are perpendicular. I'll give you the picture. Now, this picture, we're going to slightly modify it. So, I'm going to slightly modify the actual picture. This is what we're trying to prove. We're trying to show that that middle angle is 90. It is not guaranteed to be 90 right now because we haven't proved it. So when we draw this picture, don't put the 90-degree symbol in there yet. We'll put that in there later. Okay, let's write that down. We are going to prove it, all that good stuff. So we are going to do the proof here. Okay, let's get started. Let's actually talk about this proof. Now again, don't have the 90 in there yet, so ignore this. We're going to prove this here in a second, so that's not there. Okay, the first step. Since this is a rhombus, what can you tell me about it?
All sides are
All sides are
the
equal.
same.
So yeah, so this, and this are all equal. All four walls. So on your proof, AB is equal to BC, which is equal to CD, which is equal to DA or AD, however you want to write that. All four walls are equal. That's your first step. You have to have those all equal. Okay, now that we have the four walls, now, since it is a parallelogram, what do we know about the diagonals? They bisect each other. So the certain pieces up here are equal. So this piece right here is equal to that one. This piece right here is equal to this one. So they still bisect. They're not the same length. We talked about that earlier. One was a foot, one was kind of way longer than that. But we definitely talked about how to find that actual, you know, that they cut each other in halves. That was 6, 7, that previous one?
Don't you have enough to prove it now?
Okay, we have enough to prove that the two triangles are equal. Okay, so what I mean by that is that on this picture, this triangle right here is equal to this one. In fact, all four of them are all the same. Now, why I can prove that those two triangles are equal? Yeah, it's SSS, the three sides. So what we had so far, let's call this middle point if you're drawing on this. Let's call this middle point P. I still want to write all the parts. So we knew that AP was equal to CP. We knew that. We knew that, you know, the reflexive wall between the two triangles, which was BP, is equal to itself. That was the reflexive wall. We had all of that. The goal was to prove that the two triangles are equal.
Oh,
What's moving?
moving.
No, that one ignore.
So it is moving.
Okay, it moved right.
Yep, it moved.
Control F
I kind of got bogged down.
Hey, you can just walk. You're fine.
All right.
Okay. So now that we have these three markers, you guys are absolutely right. The two triangles are equal. So the triangle APB, that triangle is equal to the other triangle, which is CPB. So the two triangles are equal, and you guys said it right. It was SSS postulate. The three sides are equal. Now, why that's important? Why did I want those two triangles to be equal? Well, if the two triangles are equal, then it forces everything about the triangles to be the same. Namely, this angle right here is equal to that one. The two angles are actually the same. The two that are next to each other. See, read. Taking off?
Yeah, someone clipped my car.
Oh, sorry to hear that. So, okay. Well, good luck with that. Hey, I'll put your stuff in the corner, so don't worry about it right now. I'll take care of it. All right. So what we know is that those two angles are equal. So that angle in the middle, APB, that's equal to the other angle, which is CPB. And why that's important is if I put x's here, what do the two x's have to add up to be? 180. So if I add the two x's together, that makes 180 degrees. And if I add that, that's 2x divided by 2, and I get 90, which proves that they have to be perpendicular to each other. Because the two angles were equal. We knew that. They are corresponding parts of similar triangles. Okay? The triangles are exactly congruent. I shouldn't say similar. They're actually equal triangles. So that forces everything about the pictures to be the same. including the angles in the middle, because these were kind of visually matching parts, so that they had to be equal angles. And since they're side by side, they had to make 180, and that forced them to be 90. The only way that it could be equal and add to be 90, or add to be 180, is if they're both 90s, 90 plus 90. So that little red marker on that picture is actually true. That works on every rhombus, that you have the perpendicular lines in the middle. Now, why that's important? Because if you know that the walls are equal, the angles have to be the same, and that gets us to our next property. In fact, the next property we'll talk about this concept that everything about these pictures are equal. Not just that you have 90-degree angles, but you have everything about the pictures being the same. Okay, so next part here. Okay. So, I would like you to just write this problem down in your notes. You don't actually have to attempt to solve it. Okay? Now I gave you a bunch of work here. In fact, I'm going to bring up this picture that I have of this problem, just so you can see this. Let me bring up this problem. Yeah. All right, let me just bring it up here. Okay, this is the picture that. Let's see, this is the one with just the one with P in the middle. Okay, this is the picture you should have on that problem, correct? What's the picture? Okay, and they gave you a bunch of numbers, correct? Okay, can somebody give me, what was the walls? They said, what was AP or ABA?
15.
This is 15? Okay, we'll get rid of these other markers. Okay, what was BP?
12.
12? This is 12. And they want you to find this, and they also gave me something else. They gave me APB is what, 24? Is that right? Okay, that's an angle, right? ABD, yeah. So ABD, right?
Yeah.
Okay, so there's your markers on that picture. So if you're drawing this with that little drawing tool, you can do this. I just said put it in your notes. You don't actually have to try to attempt to solve this. There's two ways to find x. Okay, because if we just think about that last theorem we just did, what is the angles in the middle of the picture? These are all 90s. So what type of triangle is that?
Right.
It's a right triangle. We have a bunch of properties about right triangles. Number one of your groups had this yesterday. You could do Pythagorean theorem to that problem. It's a right triangle. That was one of the groups in here had that style of problem. Pythagorean theorem is where you take the legs, these are the legs, by the way. That's leg and leg. You square them, add them together, and that equals the hypotenuse squared. That's the height. It's the only wall that doesn't touch the 90. So x squared plus 12 squared equals the 15 squared. I think one of the groups in here had that. It was like one with the fence problem. It's like number 11 or something like that yesterday. You could do that. Or, if you don't like that style problem, maybe you're like, I can never set that up right. I don't know which one goes where. I don't know if the X is by itself or if the 15 is by itself. It's not the 12, obviously, because it's too small. You could do a Pythagorean, you could do Pythagorean theorem, which is this one. Let me write that up there, Pythagorean theorem. Or you could use this 24 to help me out. Because you can now do the trig functions that we did in the last chapter. What do I mean by the trig functions? You have every wall of that triangle except for one of them. So you could pick any trig function in SOHCAHTOA. These are the trig functions, right? SOHCAHTOA, that's what we did in the last test. Somebody pick one of them, not cosine. Sine. Okay, let's go sine. I'm giving you a little hints which ones to pick. So if you pick sine, sine is using the opposite wall, and it's using the hypotenuse wall, which I already had it labeled. So that's the opposite and hypotenuse wall. Well, when I set this up for sine, it's sine of the angle is equal to the opposite over the hypotenuse. And then you can multiply the 15 across. And if you type this in, you'll get the same number as somebody that's doing Pythagorean theorem. It should be like 8.9 repeating probably, or it might even just say 9. But it should be, the x that you solve should be a 9. It should be insanely close to that. Okay, did you type in 15s, type in sine 24? Do you have,
6.1.
say it again?
6.1.
6.1.
6.1.
That should be the number. So, I wonder if it's not to scale. Should be 15, or it should be 9. That's weird that they gave you two different numbers. But it should be 9. Now let me prove why it's 9. Unless somebody in the last class did their math wrong. That could be funny. Because I'm just going off of the answers the last class had. So they did the Pythagorean theorem. They said this is a 144. They said this is a 225. They subtracted this over and they got 81. And they took the square root of it, which is 9. That's funny. If it's giving you two different answers, I'm definitely going to have to submit a thing. Because this is one of the problems right out of the book.
Yeah.
So. That's funny if they got that wrong. I might have to actually submit that. Okay, questions? All right. Now, if you're doing it on that little website, you know, if you're doing it on Nearpod, you can type that stuff in. You could write it down. You can do a little pen. Hopefully that made sense. Okay. Last problem. Sorry, I skipped ahead. Sorry, I'm just trying to get you to get familiar with it. Hopefully it's working a little bit better now. Correct?
Yeah.
Okay, alright, so good to know. I won't use the computer to do it, I'll just use my iPad to run the slide. So it looks like it's actually working really well when I use my iPad. Alright, that's nice. Okay. Alright, here's the last property today. This is our last slide today. Parallelogram is a rhombus. Then the diagonals bisect the pair of opposite angles. So our last property today. So if you have a parallelogram that is a rhombus, then the diagonals bisect each pair of angles. Now let's write that down. We'll talk about it. We're not going to go through the full-on proof. We're just going to discuss.
Mr. Ward,
Yes.
was the student from last class calculator in the right setting?
Oh, I wonder. What? Can I see your calculator? Because
I got 9 too when I did that.
you got 9
In DEG?
DEG mode. When you did the sine function. Because I thought you said
did
Did you type it in
one
DEG
or
now?
whatever.
I have DEG, I've had DEG, and I did this sign
Yeah, I have
function.
it.
15 sine. 15 sine of 24.
I thought it was 9.
Yeah, because I just did the calculation with my calculator. It should have been 36, so I wonder if the book is wrong. So I might have to submit that as a review problem for the book. That's interesting. Never
When you
had
do
that.
it both ways, you get 9 and 6.1.
Weird. Weird. Alright, I'll have to look that up. That's scary. Might have to modify that on my little slideshow here. Because there's a problem right out of your book. Alright, last property here. If you have a rhombus, what do we know about rhombuses up to this point?
Parallelogram.
Parallelogram, what else?
All sides are equal.
All sides are equal. What about the angles in the middle?
They're all nice.
Squares.
They're all 90s, yeah, they're all 90s. Now, this one says that the angles in the corners are all bisected. So what that means, this angle right here is equal to the one next to it, which is equal to 3, which is equal to 4 down here. The opposite corners are actually identical. Now that is different than the ones we did yesterday when we did rectangles. Because that was one of the questions I had yesterday, was like, when we were doing rectangles, and we had diagonals going through the middle, a lot of people couldn't understand that these angles here and here are different angles. Because when you stretch it, longwise, the angles are gonna change. Because the diagonal has to flex to match the wall that's across from it. So the angles will be different. But on a rhombus, since all the walls are the same length, it's not stretched vertically or horizontally, so the angles are actually identical to each other. Now the reason why this works is because all 4 triangles are equal. We did that little proof a little bit ago by SSS postulate. So it forces certain angles to be the same, which are the ones that are corresponding, the ones that match. So if I gave you like this angle is 20 degrees, then what's angle 2? 20, and then the ones across from it are all 20s. And then you can find the angles in the other corners. And there's 2 ways to do it. Number 1, you can just do the whole triangle idea. Triangles have to add up to 180, so this would have to be 70. Because 70 plus 20 plus 90 makes 180. Or the other way, and this is probably the more difficult way to think of it, what do all the corners have to add up to be when you go across from each other? Since it's a parallelogram, what do these have to add up to be?
180.
180. Yeah, the opposite corners have to add up to be 180. They have to sum their consecutive angles. So if this is 40, like the whole corner, then this whole corner is 140. So it's the only way that it adds up. So these would have to be 70 and 70. It's the only way that it works.
Or you can do 360 minus a divided by 4.
There you go. You do that. That's a good way to do it too. So you got 3 different ways to figure it out. All right. Yeah, I'm gonna have to make a correction on that one on the slide. All right. Questions, comments about the notes today? Now, when this thing works, here's my question: do you like it?
Yes.
Yeah.
It actually kind of works. It's kind of cool. Like, next one was a poll.
Oh, see.
So you can like take polls in class, and you can actually submit. The only thing I don't like is some of the pictures don't look right. So like I have to like shrink them down a little bit. But once it works, I might just use my iPad because obviously that's working way better than just using my computer. Like it's actually snappy. Yeah, answer. But if you like this, what we'll do from now on, I'll always have the Nearpod going, and then I'll do my normal PowerPoint up here. And I'll just, what I'll do is I'll just click both at the same time. That way you actually see it on your computer so you don't have to look around people. I'll have interactive problems. I kind of like it. I think it's kind of cool. It's really easy. I just drop my actual slideshow in there and it actually just worked, which is kind of cool. I can actually share people's answers. So like, for instance,
I just kind of clicked
yeah, so that's fine. So I can share some of these answers. So the most common answer was letter C. I can share that, and you guys can see the results of me sharing the results of what the thing was. I thought that was really cool, like a really cool concept.
No.
Okay.
Which one is the right one?
27. It was 27.
Oh. Kevin? I don't need that one.
All right. Questions, comments about it? That was kind of cool. All right.
I don't like that you can't like open another tab.
Oh, because I locked it down.